Hello and welcome back to I think the fourth episode of POMODEV, and this time I have a timer here, so I will know exactly when the time I have at my disposal will finish, and I think you also will hear it as well. So without further ado, let's start the timer and let's get back to our game. So last episode didn't go very well from doing the code for the gravity. So I think I will do one of the most boring thing that a developer should do, but is necessary for this step, and that is reading the documentation. Yeah, I know. This episode won't be the most entertaining or exciting things to watch, but the scope of this series is not to be entertaining, unfortunately. Maybe I will do some recap videos in the future, but the scope of this video is to document every step that I take in order to become a beginner, a novice Godot developer. So they put this documentation online for everyone to use, and we should use it as well. I just skim it a little bit in the previous episode, and this time I need to read very carefully. So, this is the welcome page, and let's see. Welcome to the official documentation of Godot engine, the free and open source community driven to the enter the game engine. This we know. If you're new to this documentation, we recommend that you read the introduction page to get an overview on what this documentation has to offer. And we should do that. Let's go here. And let's see. Before you start, this page gives a broad overview of the engine and documentation so that you know where to start if you are a beginner, or where to look if you need information of a specific feature. So, before you start, the tutorials and resources page lists video tutorials. The tutorials and resources page lists video tutorials contributed by the community. If you prefer video to text, consider checking them out. Otherwise, getting started is a great starting point. Now, I like to watch videos in the free time. Maybe sometimes during the breaks I get some extra minutes to watch some of the tutorials. But for these videos here, I prefer to use the documentation and text tutorials. So I will just check the section out just to see what is it about. Okay, we have video tutorials and text tutorials. So okay, let's just keep an eye on this section here while we continue reading here. So in case you have trouble, you can go to the community channel. I might do that if I'm really stuck. Discord and forum. Okay. So about Godot engine. Well, here's describing what is the engine doing. Godot engine is a feature-packed cross-platform game engine to create 2D and 3D games for an unified interface. So this is describing what it can do, but that's pretty much something that I already know. Organization of the documentation. So we have the about that contains the introduction as well as information about the engine, the histories, licensing authors, and frequently asked questions. Interesting to read, not particularly useful, I think, for my use case. Getting started. I think getting started is here. Contains all necessary information on using the engine to make games. It starts with a step-by-step tutorial, which should be the entry point for all new users. This is the best place to start if you're new. Okay, very well. Let me open that in a new tab. Let's just check it out, what the other sections are for. Also, sorry for my voice, but I think I'm maybe catching a cold, so I might be having my voice change in this episode, so sorry about that. Anyway, the manual can be read or referenced as needed, in any order. It contains feature-specific tutorials and documentation. Okay, that was the part where I was trying to look about the nodes. Then we have the contributing section. I believe that is about how we can expand the work of the engine and everything, since it is open source. Community, where to find the community, and also it is the section of tutorial and resources. And finally, the class reference. Class reference documents to full Godot API, available directly within the engine script editor. Okay, I think this was the one that I was looking before. And it seems more like an advanced section, because it has every class, not only every node, but also I think every kind of resource, every kind of class, and so on. So, okay. Yeah, of course, this is a work in progress. This can be improved. We can contribute to that, etc., etc. Let's go to the step-by-step section for the beginners, the one that I open here. This series builds upon the introduction to Godot and will help you get you started with the editor and the engine. You will learn more about nodes and scenes, codes your first classes with GDScript, use signals to make nodes, communicate with one another, yada yada yada. The following lessons are here to prepare you for your first 2D game, a step-by-step tutorial where you will code a game from scratch. Okay, so we have nodes and scenes, creating instances, scripting languages, creating first script, listening to player input and using signals. So, let's start by nodes and scenes. These we know very well. So nodes are like the most little component that we can add to our game. So for example, the sprite 2D node is the component used to show a texture, or in our case a sprite. Every node has a name, editable properties, callbacks to update every frame, extend them with new properties and add them to another node as a child. So nodes, I think I know them quite well. I mean, the structure at least. And scenes are like nodes, but you know, they are a collection of nodes, and maybe also consider kinda like a template to reuse in other scenes as well, so that when I change a scene, it will reflect the change in every part of the game where the scene is present. And that's quite neat. It's quite flexible. Godot editor essentially is a scene editor, exactly. Plenty of tools for 2D and 3D scenes as well as user interface. So this is clear for me. Okay, creating our first scene, we already did that. We went with the 2D. There are 2D node, 3D node, and user interface node, the data control node. Okay, these are not mandatory, but okay, this is a tutorial to use the label to show text. Change your own properties. We saw that is the column right there at the right side. You can move your label node with this thing here. Okay, this is for moving. Now I don't want to screw up this because it will change quite a lot of things. Okay, running the scene. These I know. Setting a main scene. Actually, I don't know. I should maybe do that already. Maybe like this. I think I already did this. Okay. Okay, this was something that I read before, and it's crystal clear how it works. Let's see the next step, creating instances. Also, let me know in the comments if I have missed something about this. But well, the things that I already know, that I already learned, I can kind of skim it. Creating instances. So, yeah. In the previous part, we saw that a scene is a collection of nodes organized in a tree structure with a single node at its root. Okay. You can split your project into any number of scenes. Okay, that's... Yeah, we basically make a new scene, text scene. So TSCN is the acronym for text scene. Here's an example of a ball. It's composed by a rigid body 2D node at its root named ball, which allows the ball to fall and bounce on walls. A sprite 2D node and a collision shape 2D. Yeah, and then the ball is reused in other instances as well. Very clear. Let's keep in mind rigid body 2D, because I really, yeah, this takes us to the class reference that it's more advanced, it's getting many more technical. Okay. What? Oh, no, I was here. Creating instances. Okay, once you have a scene, it works as a blueprint. You can reproduce in other scenes and so on. That's good. Yeah, here it makes me import just to see how the thing works. Project contains 2. Okay. Let me just... Let's add the ball to the child. Yeah, okay, so this button here, instantiate child scene. Okay, so I can take another scene and instantiate it. Of course, I cannot instantiate the same scene where it is based on, but okay, that works like that. I might download this just to, you know, have it ready. Let's see, can I? Oh, okay. Yeah, I know. Okay, so I might take a look at this also. You know, we need to take everything that the docs give us. So if you have a starting point of practice or to look better to what is explaining, it's better to download it and take a look rather than just ignore it. Okay, so this is how to import the project. It's pretty much clear, and that's it describing the project. So adding the ball as a child, we add the scene, and then we drag it and place it wherever we want, and we can do it multiple times. Got it. Editing scenes and instances. There is more to instances with the feature you can change the properties of one ball without affecting the others using the inspector. So I guess, okay, so if I have one instance here, I can change the things that are on the right and it will apply only to that ball. Okay, that's clear. Or change the default properties by editing the ball. So basically global edit and individual or entity edit. Okay, let's try this. Open ball.tcn. Okay, excuse me for a moment. All right, sorry, I had to take some tissues because it was getting very difficult to read. All right, let's resume. Why this block? I don't know. Okay. Damn it. Oh no, I messed up. Just a moment. All right, I should be back for real now. So, we were saying, sorry about that. Editing scenes and instances. So we have individual editing and global editing. We can change stuff on the right and like change the bounciness of the ball. and then we can change the individual instance. Yeah, exactly. You may notice we are unable to change the values of the physical material of the ball. This is because physical material is a resource and needs to be made unique before you can edit it in a scene that is linking to the original scene. To make a resource unique for one instance, right click on it on the inspector and click Make Unique in the contextual menu. Resources are another building block of Godot games we will cover in a later lesson. Okay, so there are also resources here that may be blocked because you need to edit in bulk inside the scene, I guess. Scene instances as a design language, okay. We instances and scenes offer access to the design language. We design Godot around this concept from the ground up. We recommend dismissing architectural code patterns when making games in Godot, such as model view controller or entity relationship diagrams. Instead, you can start by imagining the elements player will see in your game and structure your code around them. For example, you could break down a shooter game like so. Stage, where you get weapons, you get enemies and missiles. Then we have another enemy here. Then we have other weapon, player, ship, obstacle, HUD, and market. So basically it's kind of a different view on the architecture of the game. Fortunately, I very used to reasoning like this with the object oriented. And then we have an example of open world game. Okay, this I think is actually clear. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Designing based on scenes makes development faster and more straightforward, allowing you to focus on the game logic itself, because most game components map directly to a scene. Using a design based on scene instantiation means you need little other architectural code. Okay, that's clear. Okay. So instances is the process of producing an object from a blueprint. As many handy uses with scenes, it gives you the ability to divide the game in your reusable components, tool to encapsulate complex systems, and language to think about your game project. Okay. And instances are also clear for me. Now we have scripting languages that I think it's very straightforward. Just to give a little summary, Godot can use GDScript, C# and C and C++, but I will stick to GDScript. I kinda like the simplicity of it, and I don't need to have very complex structure to my game, so I think it's enough. He gives a rundown of GDScript. Fortunately, I don't need this because not that I don't need to learn GDScript. I don't need to get introduced to a language because I used to code in different languages. I used for a period Ruby when I was working in my games in RPG Maker. I used JavaScript and so on. So I'm quite used to code. Okay, these are giving reasons for why we don't use Python or Lua directly. Net C#, C++. Okay, this we can quite skim. Creating your first script. Okay, so create a new project and we need to create a sprite2D known to display in a game. So we create a sprite2D. We set the icon here, and then we attach a new script like we did in the last video. Change the template from node default to object entity to start with a clean file. Okay. Yeah, exactly. So every node, every script that we create extends from an existing class. So basically inherits, it's a default inheritage of all the functions of the parent class. Every GDScript file is implicitly a class. The extends word defines and extend. In this case is sprite2d. Okay, that's clear. In GDScript, if you omit the line with the extend keyboard, your class will implicitly extend ref counted, with Godot used to manage your application memory. Okay. Base class for any object that keep a reference count. Resource and many other helper objects inherit this class. Okay. Interesting, but still, I think very advanced here. So let's just keep with the script, let's say. Inherited properties include the ones you can see in the inspector doc, like our node's texture. So it is referencing the things here, and it is nicely divided. So we have the sprite2d specifics, then we have node2d, which sprite2d inherits, canvas item, node, and so on. That's really, really useful. Okay, we write an hello world. So he is writing a function named init and printing something. Let's break it down. Function keyword defining function name init. This is a special name for our class construction. The engine calls init on every object or node upon creating it in memory. I think I saw also the ready function. So it will be interesting to see what's the difference between the ready function and the init function. I will need to check that out. Okay, so with the init, it prints hello world on the console. So the console is the one right here in the output. So useful for, you know, debugging stuff. Turning around, it's time to make our node move and rotate. To do so, we are going to add two new variables. So variables are declared like this, and I think this is a constant. Angle is Godot, works in radians by default. That's something that we need to keep in mind, even though I don't think we will need to rotate sprites, maybe for animation. To move our icon, we need to update the position and rotation every frame in the game loop. We can use the process virtual function of the node class. If you define it in any class that extends the node class, like sprite2d, Godot will call the function every frame and pass it. Okay, this is our update function, the one that I also use in Pico 8 for the game loop, and basically checking for everything that was running constantly. While init, it's basically the same as the one in Pico 8. Games work by rendering many images per second. Each color frame, okay. The engine developers do their best to update the game. Okay, that's something I know. At the bottom of the script, we define a function from process. Okay, we have this delta parameter that, from what I understand, it's the basically the time that has passed from one frame to another. Yeah, okay. Delta, the time elapsed since the last frame. So this is basically to support multiple frame rates and support also maybe older GPU graphics that doesn't support to go at 60 every time. Notice how process like init starts with a leading underscore, right? By convention, Godot virtual functions, that is to say built-in functions you can override to communicate with them, and just starts with an underscore. Good to know. Then I inside the function, rotation plus angular speed times delta. Yeah, that's rotates basically constantly the sprite. I think it's something that I can also try for, you know, just to test. Let's make our object empty. And test script. Let's call it this. Well, let's call it already like player.gd, but not in scenes. I want it in scripts. I don't know why it defaults to scenes for some reason. Okay, so we have our speed, which let's try 200, and then we have our angular speed equals pi. Oh, it's already time to take a break. Well, let's just finish this part here, and then we can call it out. So speed and angular speed, then we call our func process delta, and we change our rotation. So rotation, I guess, is a parameter of sprite 2D. No, it's a parameter of, okay, it's a property of node 2D transform rotation. So there was, I think, an option to show the name. What if I do like this? No. So anyway, we need to change rotation to angular speed, which I forgot. Yeah, score times delta. So it basically ignores the speed. Maybe it uses it later. Yeah, probably use it later to move forward. But let's just focus on this test here. So now, if I do this, what is this about? Expect, yeah. Okay. Now, if we test it, let's see. Yeah, our sprite is rotating in a very pixely way. I actually love how it rotates. It basically interprets the pixels. Okay, so our script works. We will soon have our gravity script for our player, but we need to take it one step at a time. As you can see, it might be very boring going through the documentation, but it's a very mandatory step if I need especially to understand how Godot wants me to speak to him for making things work. So if you stick to this very boring video, I thank you very much for watching, and I will see you next time. Take care.